Hello, good morning everyone. So in today's class, we will see about fluid mechanics and introduction to fluid mechanics. So what exactly is fluid mechanics, and in detail we will study about the introduction part with respect to fluid mechanics. So I am sharing the screen. I hope it is visible to you. So what we are going to study: definition of fluid, properties of fluid, that is mass density, specific weight, specific gravity, specific volume. Apart from that, we will study what do you mean by cohesion, adhesion, and viscosity and its types, and Newton's laws of viscosity. Apart from that, we will also see in detail about capillarity rise and fall in a vertical tube, surface tension, and derivation for surface tension inside a water droplet, a soap bubble, and liquid jet. And also we will solve some problems on these properties. So introduction: in general, matter may be distinguished by the physical forms known as solid, liquid, gas. This already we have studied at school level also. That is, matter, it consists of solid, liquid, and gas. But apart from this, one more addition to this can be done, which is termed as fluid. So what exactly is fluid? The liquid and gaseous phases are generally combined and given a common name, fluid. Combination of solid liquid and liquid gas are termed as fluid. Example for that is oil, honey, and petrol. Apart from this, many other examples are also there, but these are the common examples, that is oil, honey, and petrol. Solids differ from fluids on account of their molecular structure. That is how solids differ from fluids with respect to their geometry, how the molecules are arranged. In case of solids, the molecules are closely arranged, whereas in case of liquids, there is some space in between the molecules. The intermolecular forces are larger in a solid, smaller in a liquid, and extremely smaller in a gas. That is, this also you have studied at school level, how the molecules are arranged in case of solid, gas, liquid, and gases. So in solid, they are very closely arranged. In liquids, they are somewhat space between the molecules, and in gases, the molecule are free to move anywhere. So what exactly is fluid mechanics? That is, fluid mechanics, it is a branch of civil engineering that deals with fluids at rest or in motion. So normally what we think is, suppose honey is there. If you keep the honey in a container, you will assume that the fluid is at rest, although it is moving inside it. For example, if you slowly remove the honey from the bottle, it will start floating on a glass, or a vessel if you take. So what fluid mechanics does, it not only studies the study of fluids at rest as well as in motion. It has traditionally been applied in such areas as design of pumps, compressor design of dams and canals, design of piping and ducting in chemical plants, the aerodynamics of aeroplanes and automobiles. Apart from the normal parts, these what we can say, fluids, they are traditionally applied to areas such as design of pumps, compressor, design of dams, canal, etc. In recent years, fluid mechanics is truly a high-tech discipline, and many exciting areas have been developed, like the aerodynamics of multi-story building, fluid mechanics of atmosphere, sports, and microfluids. So, in the recent times, what is happening is a number of research areas is being developed in case of fluid mechanics, such as aerodynamics of multi-story buildings, fluid mechanics of atmosphere, sports, and microfluids. Now, coming to our definition of fluid. So, how you will define a fluid? A fluid is a substance. See, we can define fluid in easy simple way also, that is the combination of solid liquid or liquid gas. But most precise definition for fluid is, a fluid is a substance which continuously deforms under the action of shearing forces, however small they may be. So the size of molecules does not count or does not have any effect on the type of fluid, however they are small may be. If a fluid is, how we are defining fluid, it is a substance which deforms continuously under the action of shearing forces. So if suppose shearing forces are there, these shearing forces, what they are doing, they are deforming the fluid continuously. Conversely, it follows that if a fluid is at rest, there can be no shearing force acting, and therefore all forces in the fluid must be perpendicular to the planes upon which they act. See here, as we have stated that fluid mechanics is nothing but study of fluids in motion as well as at rest. If they are in motion, then certainly what you can say, shearing forces will act on it, due to which it gets deformed. But if suppose the fluid is at rest, then there will be no shearing forces acting on it. At that time, what is happening, all the fluid forces in the fluid must be perpendicular to the planes acting upon it. If you see in the figure, the first figure denotes the fluid is at rest, so the forces are acting perpendicular to the planes upon which that, whereas in the second case the fluid is moving and the shear force is acting and it is causing a deformation. Now we will see properties of fluid. So different what you can say, properties of fluids are present. So these are very important. Why they are important? In order to understand the concept of fluid mechanics, you need to understand the basic properties associated with it. See here, fluid mechanics is a very interesting subject, but to understand the concept of fluid mechanics, it is somewhat geotechnical engineering like. If you understand the concept, it is very easy, but if you fail to understand the basic concept, it becomes very difficult. So the mass density or specific mass, how we are defining mass density or specific mass, it is the mass per unit volume of the fluid. So how we are defining density? It is nothing but a ratio of mass of fluid to volume of fluid. So it is denoted by the symbol rho. Rho is equal to m by v. If suppose a small mass dm is acting and small volume is present, then we will denote rho as dm by dv. And the SI unit for mass density is kg per meter cube. Now coming to our second property, weight density or specific weight. So how you will define weight density or specific weight? It is also similar to your mass density, but the only difference is with respect to mass and weight. Don't get confused. Mass is different, weight is different. Weight, it takes into account acceleration due to gravity, whereas mass does not take into account acceleration due to gravity. W is equal to mg. Remember this. So weight density or specific weight of a fluid is the weight per unit volume. That is gamma is equal to weight of fluid by volume of fluid. W by V or dW by dV. So what will be the unit of weight? As we are saying, W is equal to mg. Acceleration due to gravity is also taken into account. So the unit becomes Newton. And unit for volume is meter cube. So it becomes Newton per meter cube. So as I said that you have to remember this relation, that is relation between mass density and weight density. We have gamma is equal to weight by volume. So weight is nothing but m into g. So gamma is nothing but mass by volume is rho. So your gamma is equal to rho into g. So this also will be helpful for you, this formula, that is relation between specific weight and specific mass. Gamma is equal to rho into g. This we can is very helpful when you solve the problems. Now coming to the next property of fluid, that is specific gravity, or it is also known as relative density. See here, don't get confused. Most of the times you have to remember that specific mass and mass density is same, specific weight and weight density is same. Similarly, specific gravity or related density is also same. So how you will define the specific gravity or relative density? It is the ratio of density of fluid to the density of standard fluid. It is denoted by the symbol S. So S is equal to rho fluid by rho standard fluid. So because both the unit for density is kg per meter cube, in both the cases we are calculating the density. So the units get cancelled, kg per meter, kg per meter cube. So specific gravity is a dimensionless quantity and has no unit. Now the question comes, what do you mean by standard fluid? Generally water is considered to be a standard fluid and its density is taken as 1000 kg per meter cube. So once again, I am explaining, you just remember what exactly is specific gravity. It is nothing but density of fluid. It may be any fluid, oil or so you can say petrol, diesel, whatever it may be, divided by density of standard fluid. So a standard fluid is nothing but water. Its density is 1000 kg per meter cube. That you have to remember. And one more thing, it is specific gravity is a unitless quantity, dimensionless quantity. This type of question will be asked in competitive exam. That also you have to remember. Now coming to one more property of fluid, that is specific volume. So how you will define specific volume? As the name itself indicates, specific volume. We are very much concerned about volume. So it is the ratio of volume per unit mass of the fluid. V is equal to volume by mass, V by M, or if it is a small volume, it will dV by dm. So if you see here, it is nothing but reciprocal of density of fluid. Density of fluid was mass by volume. Specific volume is volume by mass. So SI unit also will be a reciprocal, that is meter cube per kg. I hope you have understood the basic concepts of basic properties of fluid. Once again, before going to solve the problems, I am just revising it. You just listen it to. So, what exactly is a fluid? A fluid is a combination of solid liquid or liquid gas. For example, oil, honey, these are milk. These all are considered as fluid. Or if you want a precise definition, a fluid is a substance which undergoes continuous deformation under the action of shearing forces. If the fluid is at rest, there will be no shearing force acting on it. Even if it is acting, it will be perpendicular to the plane of direction of force applied. So what exactly is fluid mechanics? Fluid mechanics is the branch of civil engineering that deals with fluids at rest as well as in motion. Now coming to what you can say, different types of different properties of fluid, starting with the density of fluid. It is nothing but ratio of mass of fluid by volume of fluid. SI unit is kg per meter cube. Whereas next comes weight density or density of fluid. It is the ratio of weight of fluid to volume of fluid. Then SI unit is Newton per meter cube. Next is, and one more thing, relation between uh, specific weight and density is specific weight is equal to density into acceleration to gravity, where G is 9.81 meter per second square. Next is specific gravity or relative density. It is the ratio of density of fluid to density of standard fluid. It is a dimensionless quantity and no SI unit is there. And the standard fluid is water whose density is 1000 kg per meter cube. Lastly, specific volume is nothing but it is the reciprocal of density of fluid. That is, it is defined as ratio of volume of fluid to mass of fluid, and its SI unit is meter cube per kg. Now, with the help of this data, we will calculate one problem. So what the problem states, calculate a specific weight, mass density, specific volume and specific gravity of a liquid having a volume of 4 meter cube and weighing 29.43 kilonewton. Assume missing data suitably. So before going to solve any problem, not only in fluid mechanics, but any other subject, the basic rule is you have to read the question twice before moving forward. So we will just repeat the question. You will listen it carefully. We need to calculate specific weight, number one. Next, mass density, number two. Specific volume, number three. Specific gravity, number four. So four unknowns are there. That is gamma is not known to you. Rho is not known to you. V is not known to you. S is not known to you. So what is being given? The liquid volume is given. That is capital V is given to you. It is 4 meter cube and specific weight, that is W, is given to you. How much it is? 29.43 kilonewton. Any other data can be assumed suitably. So any other data, I mean, in the sense density of water you can assume as 1000 kg per meter cube. So as specific weight is given, you can use the formula for sp- specific weight. That is, specific weight is equal to weight by volume. So weight is how much? 29.43 kilonewton is there. So we will convert it into Newton. 29.43 into 10 raised to 3 divided by how much is the volume? 4. So it comes out to be 7357.58 Newton per meter cube. You can also cross check it if you have the calculators with you. So weight is given, specific weight is not given, weight is given. So with the help of which we have calculated specific weight. Weight of fluid is given to you, weight of liquid, sorry, and volume of liquid is also given to you. So with the help of both of these, we have calculated the specific weight. Now we need to calculate rho. Normally rho is equal to m by v. V is known to you, but m you don't know. So which relation you can use? That is W is equal to mg. W is known to you, 29.43 into 10 raised to 3. M into G is also known to you. See, assume missing data suitably was given to you. So G you can assume is 9.81. In some cases, or sub textbook, you can take G is equal to 10 also, but it is all because it is almost equal to 10 only, 9.81. So this M comes out to be 3000 kg. Now density equal to mass by volume. Mass is 3000, volume is 4. So how much it comes out to be? 750 kg per meter cube. Now small v. What is small v? Capital V by M. That is, small v is nothing but specific volume. It is the ratio of volume of fluid to mass of fluid. Volume is 4. Mass just now you have calculated 3000. So this comes out to be V equal to 1.33 into 10 raised to minus 3 meter cube per kg, because volume is in meter cube and mass is in kg. So it comes out to be meter cube per kg. Finally, specific gravity. What is specific gravity formula? Sg, it is equal to density of fluid to density of standard fluid. Density of fluid you have calculated 750 here. If you see 750 divided by density of standard fluid is nothing but water 1000. So Hg comes out to be 0.75. So the problems looks easy now because you have remember all the, what you can say, formulas. If you don't remember the formulas, it becomes very difficult. So the four standard formulas that you have to remember. One more problem we will solve, then you will get a clear picture of it. What the second problem states? Calculate specific weight, density, specific volume, and specific gravity. And what we need to calculate? Calculate specific weight. W we need, gamma we need to calculate. Next, density rho we need to calculate. Specific volume small v we need to calculate, and specific gravity S we need to calculate, Sg. Of what? One, if 1 liter of petrol. 1 liter of petrol means volume of petrol is given to us 1 liter. Weighs 6.867 Newton. So what is 6.867 Newton? Weight of oil, sorry, petrol is 6.867 Newton. So we will note down the things which are given to you. Capital V is equal to 1 liter. So 1 liter is nothing but 1 divided by 1000. It comes out to be 10 raised to minus 3 meter cube. W is given to you as 6.867 Newton. So W is known to you, V is known to you. You can easily calculate the specific weight. Specific weight is nothing but weight of fluid by volume of fluid. 6.867 divided by 10 raised to minus 3, it comes out to be 6886867 Newton per meter cube. So the specific weight of petrol is 6867 Newton per meter cube. Now specific volume small v is equal to capital V by M. So again we need to calculate M. So if you remember, in most of the cases or most of the problems, in order to calculate mass of fluid, you will use this formula, that is W is equal to mg, or M is equal to W by G. W is just now, W is given to you. it is 6.867 divided by 9.81. If you do, it comes out to be 0.7 kg. So V specific volume is nothing but volume by mass of fluid. Volume is 10 raised to minus 3, that is 1 liter, divided by mass is 0.7. So specific volume comes out to be 1.4 into 10 raised to minus 3 meter cube per kg. So you be particular with SI units. Don't get confused. If you remember the formula, you can easily remember the SI units also. Last but not the least, how you will calculate density, mass by volume. Mass just now you have calculated 0.7, volume is 10 raised to minus 3. If you do the calculation, it comes out to be 700. Density of petrol is 700 kg per meter cube. Even if you go to petrol pumps for filling your tanks of two-wheeler or four-wheelers, you might observe that on the petrol pumps there will be written as density of petrol and all. You just observe it next time whenever you go. Finally, specific gravity of petrol. How you will calculate density of fluid by density of standard fluid, that is density of water. Density of petrol just now we have calculated as 700 divided by volume is what you can say density of water is 1000. So if you do the calculation, it comes out to be 0.7, and it is a dimensionless quantity. So I hope you have got a command on the numericals. So I hope I will give you 2 minutes. You just try to solve this problem. Specific gravity of a liquid is 0.7. Find mass density, specific weight. Also find the mass and weight of 10 liters of liquid. So what is the question? I will read it once again. The specific gravity of a liquid is 0.7. Sg is given, vice versa of the previous problem. Here specific gravity is given to you, Sg is given to you 0.7. Find mass density, specific weight. You need to calculate rho, you need to calculate gamma. Also find mass and weight of. Also find m, small m, W of 10 liters of liquid. So the volume of liquid is given as 10 liters. So I will just give you an hint, that is specific gravity of fluid is density of fluid to density of standard fluid. Density of standard fluid water is 1000 kg per meter cube. So using that data, you can easily calculate the remaining things. I hope you will remember this. If you have any queries, or what you can do is you can take 2 minutes and try to solve it, or else you just comment on this section what are the results you have obtained for this problem. If you are unable to solve this problem, tomorrow I will show you how to solve that problem. If you have any queries, you can just make a comment or pin me or mail me at nadim@kben.university. Now coming to the next topic. So before moving to the next topic, I will just do a recap for the things which we have studied today. That is what you can see. What is fluid mechanics? Branch of civil engineering that deals with study of fluids as well as at rest. So what is a fluid? A fluid is a combination of solid, liquid or liquid gas, oil, petrol, honey, etc. Next, what is fluid mechanics? Branch of civil engineering that deals with study of fluids at rest as well as in motion. So more precisely, how you will define fluid? A fluid is a substance which undergoes continuous deformation under the action of application of shearing forces. If it is moving, if it is at rest, no shear force will act on it. Even if though it act, it will be perpendicular to the plane of paper. Now, apart from this, we need to understand what are the properties of fluid. So starting with the density of fluid, it is nothing but how it is defined. Density of fluid, it is nothing but mass of fluid to volume of fluid. So the SI unit is kg per meter cube. It is also known as specific mass. Next, specific weight or weight density. It is defined as the ratio of weight of fluid to volume of fluid. SI unit is Newton per meter cube. One more thing you have to remember, that is W is equal to mg. So with the help of this formula, you can establish a relation between specific mass and specific density. That is gamma is equal to rho into g. So this will be helpful for solving the problems. Next comes a specific volume. So it is defined as the ratio of volume of fluid to mass of a fluid. It is the reciprocal of specific mass, and SI unit is meter cube per kg. Last but not the least, what do you mean by specific gravity? Specific gravity is nothing but it is defined as ratio of density of fluid to density of standard fluid. So there is no SI unit for it. It is a dimensionless quantity. And the SI, what you can say, standard fluid is taken as water, whose density is 1000 kg per meter cube. So after that, we solve some problems because only few minutes are remaining. Instead of starting a new, what you can say, topic, I will just solve the problem because no response have been received from your side. I think still you have not not got the concept with the respect to the solving of the problems. You just listen it carefully. We will close this now. In the next class, we will start with cohesion and adhesion. So what is the problem? Specific gravity of a liquid is 0.7. So Sg is given to you as 0.7. Okay. Next, what you need to calculate? Mass density. Rho you need to calculate. Weight, specific weight. Gamma you need to calculate. Rho you need to calculate. Gamma you need to calculate. Next, also find mass and weight. Small m and W also you have to calculate. What is given to you then? 10 liters. Capital V is given to you. That is volume of liquid is given to you. So using this formula, you can calculate. Because specific gravity is given to you, first foremost thing what you have to do is you have to convert the given volume from liters to meter cube. What may be the given value of liquid in liter? You just multiply it by 10 raised to minus 3. It will come in meter cube. After that, what is given to you? S is given to you. Specific gravity of liquid is given to you 0.7. It is nothing but ratio of density of fluid to density of standard fluid. So what we are doing, in place of density of standard fluid, we are taking it to be equal to 9.81 into 1000. How we are doing it? Because gamma is nothing but rho into g. If you remember, gamma is also known as rho into g. Rho is 1000, g is 9.81. So if you multiply both, it will come as to be 9810. So your gamma will be equal to 0.7 into 9810. So it comes out to be 6867 Newton per meter cube. So your gamma is equal to rho g. In place of gamma, you can substitute 6867. Rho into g is 9.81. So rho comes out to be 700 kg per meter cube. Now you have got the values of density as well as specific weight. That is, density is equal to 700 kg per meter cube and gamma is equal to 6867 Newton per meter cube. Now, specific gravity. How much is the specific gravity? It is nothing but the density of fluid to the density of standard fluid. So S is equal to 0.7. Rho standard is nothing but that is density of standard fluid is 1000. So if you just cross multiply, it comes out to be 700 kg per meter cube. Now, lastly, you need to calculate rho. Rho is nothing but mass by volume. That is, density of fluid is equal to mass of fluid by volume of fluid. So, density just now you have calculated as 700. Volume is nothing but 10 into 10 raised to minus 3. So, if you do the calculation, it comes out to be 7 kg. I hope you are familiar or you will be perfect with the problems now. Only four formulas are there. If you remember the four formulas, then easily you can, what you can say, calculate the things. That the density is equal to mass by volume. Next, specific weight is equal to weight by volume. W is equal to m into G. Next, specific volume is equal to volume by mass of fluid. Last but not the least, specific gravity equal to density of fluid by density of standard fluid. And SI unit also you have to remember. SI unit of density is kg per meter cube. SI unit of specific weight is Newton per meter cube. Specific SI unit of specific volume is meter cube per kg. There is no SI unit for specific gravity. And density of standard fluid water at 4 degrees Celsius is 1000 kg per meter cube. And W is equal to mg. And G values is taken as 9.81 meter per second square. If you remember this much formula, and one more thing, how to convert a given volume from liters to meter cube, multiply by 10 raised to minus 3, you will get the values in meter cube. So this is with respect to the introduction part. In the next class, we will see what do you mean by cohesion and adhesion. So it is also a very interesting topic. We will continue that tomorrow. I hope you all have a good day ahead. Thank you. If you have any doubts or problem with respect to the today's content, you can just contact me at nadim@k1.university, and also you can just ping me. I will reply to your queries. Have a nice day.